Hello and welcome to the Advanced Software Architecture course. My name is Imed Hammouda. This is a lecture on architectural styles, part 5. In this lecture, we will present allocation styles. We will start with MapReduce style. For many applications with ultra-large datasets, sorting the data and then analyzing the group data is sufficient. The problem that MapReduce style solves is to efficiently perform a distributed and parallel sort of a large dataset and provide a simple means for programmers to specify the data analysis to be done. The whole computation is automatically split over a cluster of nodes. MapReduce style provides a framework for analyzing a large distributed set of data that will execute in parallel on a set of processors. Three elements can be identified in this style. Map is a function with multiple instances deployed across multiple processors that perform the extraction and transformation portions of the analysis. Reduce is a function that may be deployed as a single instance or as multiple instances across processors to perform the load portion of extract transform load. The infrastructure is a framework responsible for deploying map and reduce instances, shepherding the data between them, and detecting and recovering from the failure. Obviously, the advantages of this style are performance, scalability, and flexibility. Performance gets improved through concurrent computation. Scalability is achieved through the increase of data size. And flexibility is possible because of reconfigurable computation nodes. As for the limitations of this style, one could observe that if we don't have large datasets, the overhead of MapReduce is not justified. Also, it is not possible to divide dataset into similar size subsets. The advantages of parallelism are lost. Further operations that require multiple reduces are complex to orchestrate. Here is a question for reflection. For what type of applications is MapReduce suitable as architectural style? Think of social network analysis applications and business intelligence systems. Last but not least, we discuss MultiTier. MultiTier architecture segregates functionality into separate segments in much the same way as the layered style, but with each segment being a tier located on a physically separate computer. Each tier is completely independent from all other tiers except for the immediately above and below it. The nth tier only has to know how to handle a request from the n+1th tier, how to forward that request on the n-1th tier, if there is one, and how to handle the results of the request. Communication between the tiers is typically asynchronous in order to support beta scalability. N-tier architectures usually have at least 3 separate logical parts, each located on a separate physical server. Each part is responsible for specific functionality. When using a layered design approach, a layer is deployed on a tier if more than one service or application is dependent on the functionality exposed by the layer. The grouping of components into tiers may be based on a variety of criteria, such as the type of component, sharing the same execution environment, or having the same runtime purpose. The main benefits of multi-tier architectural style are maintainability. Each tier is independent of the other tiers. Updates or changes can be carried out without affecting the application as a whole. Scalability. Tiers are based on the deployment of layers. Scaling out an application is reasonably straightforward. Flexibility. Each tier can be managed independently. Flexibility is increased. On the limitations side, the main weakness with the multi-tier architecture is its cost and complexity. For simple systems, the benefits of the multi-tier architecture may not justify its upfront and ongoing costs in terms of hardware, software, and design and implementation complexity. Here is a question for reflection. Can you think of other allocation architectural styles? Think of allocating development work to multiple development sites, external subcontractors, or open source communities. Here is a wrap-up of the Architectural Styles lecture. First, architectural styles are metaphors, emphasizing subdivision of functionality, topology, and interaction style. Second, as technology and business evolve, new styles may emerge responding to new challenges. Third, you should keep in mind that the architecture of a software system is almost never limited to a single architectural style, but is often a combination of architectural styles that make up the complete system. Finally, it is worth noting that architectural styles are not disjoint, but may overlap with regard to their properties. This is the end of the Architectural Styles lecture, part 5. Thank you for watching.